Welcome to Physics Made Easy channel. Average life or mean life of radioactive element. Average lifetime of radioactive element can therefore be obtained by calculating total life of all the atoms of the element, dividing it by total number of atoms present initially in the sample. Let n naught be the number of atoms at time t is equal to 0. N number of atoms at time t. Dn number of nuclei that disintegrate in small time dt. The lifetime of each of these Dn atoms lies between the time period t and dt. If dt is very small, that is dt is approximately equal to 0 or dt tends to 0. In mathematical language, dt tends to 0. The age of Dn atoms. Now, what we have just concluded, I will like to rewrite it here and then drive accordingly. We have n naught atoms at time t is equal to 0 and n atoms at time t. And now Dn atoms decayed in time d plus dt. In the next time dt, in the next time dt, after this t, in the next time dt, Dn atom decayed, or Dn atom decayed between t and t plus dt. Now, if this time dt is very small, then we can say that the life of Dn atoms is t. The age of each of Dn atoms is t. Total age of Dn atoms is t into Dn. Is t into Dn. Now, tau. Tau is total life divided by n naught, where n naught is total number of atoms at time t is equal to 0. Total life will be calculated from this. The life of Dn atoms is this. And now, the life of n naught atoms, that is, we will integrate from 0 to n naught t into Dn. Now, this is total life of all n naught atoms. The life of Dn atoms is t into Dn, and the life of n naught atoms is integral of this 0 to n naught. So this is total lifetime of all atoms. This factor is basically total lifetime of all atoms. For paucity of space, I will like here, right here. So this is total lifetime. So I will try to write it by TL. Total life is just of all the n atoms 0 to n naught T into Dn. Now we are well familiar with this formula, n is equal to n naught e raised to power minus lambda t. Now differentiating it, this will be n naught into minus lambda into e raised to power minus lambda t. And here we are differentiating with respect to t. This is dn by dt. Note, we are differentiating with respect to t. Now, dn will be equal to minus lambda n naught e raised to power minus lambda t into dt. Now, if we have to integrate it, if we want to integrate it, so this is dn. I will fill the value here. I will call this as equation number 1. This as equation number 2. Now use equation 2 in 1. What we shall be having, average life tau is equal to TL divided by N naught. Now substituting the value of TL, this is equal to integral minus 0 to N naught lambda N naught into T e raised to power minus lambda T dt divided by N naught. Both of them cancel. From here, tau is equal to minus 0 to N naught lambda t e raised to power minus lambda t dt. Now, we will do some tinkering with this integral. There is no element from n naught to infinity. If we extend the limit from n naught to infinity, it does not make any change or it does not affect it. So this is lambda t e raised to power minus lambda t dt. Now if I divide by lambda and multiply here by lambda, then we shall be having tau is equal to 1 by lambda integral 0 to infinity, and it will be x e raised to power minus x dx. Here we have used substitution. X is equal to lambda t and dx is equal to lambda dt. The value of this is 1 and tau is equal to 1 by lambda. So average life is 1 by lambda. This is what we have learned. We know that half-life TH is 0.6931 divided by lambda. And now let it be equation number 3 and it be equation number 4. T half-life is equal to 0.6931 into tau, where tau is average. Tau is 1 by lambda, or tau is T half divided by 0.6931, or tau is 1.44 T half-life. This is its value. And now the next very important topic is important for JEE Main and JEE Advanced student. For NEET students, this topic is a bit on the difficulty side. In CBSE board, even such questions are asked. Now, we are familiar with this decay law. N is equal to N naught e raised to power minus lambda t. N by N naught is equal to e raised to power minus lambda t. This is probability of survival. Probability of survival. This is N by N naught is equal to e raised to power minus lambda t. Then probability of decay. Probability of decay. This is equal to 1 minus N divided by N naught. This is 1 minus e raised to power minus lambda t. This is probability of decay. And now, remember once more, probability of survival is probability of survival is equal to e raised to power minus lambda t. Probability of decay e raised to power this. So remember these two things. And then we have got the concept of activity. Activity also follows the same law. How? Activity A is dN by dt, and this is equal to d over dt and not e raised to power minus lambda t. A is equal to n naught into minus lambda e raised to power minus lambda t. A is minus dn by dt and this is minus this, and here we have got minus already. So A comes out to be minus minus plus n naught lambda e raised to power minus lambda t. Now n naught lambda is equal to A naught. It means this equation A becomes A is equal to A naught into e raised to power minus lambda t. The formula for activity and decay, number of undecayed or active nuclei is same. Now let me focus on the formula of number of undecayed nuclei, which is this minus lambda t. So these two formulas, one is for number of undecayed nuclei, other for activity A. They are similar. And also the ratio of present activity to activity at the time of creation of sample is equal to number of active nuclei to number of active nuclei at the time of creation of sample. This is 1 by 2 raised to power n, where n is number of half-lives, or we can also write it as A divided by A naught is equal to n divided by n naught is equal to 1 by 2 divided by small t, and this is capital T. Capital T is half-life, and this is 1 by 2. Next is Becquerel. One Becquerel is defined as rate of decay. One disintegration per second is called 1 Becquerel. 1 Rutherford is 10 raised to power 6 decays. And 1 Rutherford is 10 raised to power 6 decays. 1 Rutherford is 10 raised to power 10 decays. The activity of a radioactive sample is said to be 1 Rutherford when 10 raised to power 6 decays are taking place in every 1 second. I doubt this statement. And this 1 Rutherford is 10 raised to power 10 decays per second. It should be either 6 or 10. I will confirm it. And next is the activity of a radioactive sample is said to be 1 curie. And if 3.7 into 10 raised to power 10 decays takes place every second. The most popular unit is millicurie. Millicurie is 3.7 into 10 raised to power 7 decays per second. 1 microcurie is 3.7 into 10 raised to power 4 decays per second. So these were the units, important units, and Rutherford is also an important unit. First of all, Becquerel 1 decay per second, Rutherford 10 raised to power 10 decays per second, and then Curie 3.7 into 10 raised to power 10 decays. or disintegrations per second. Millicurie is practical unit, 3.7 into 10 raised to power 7 decays per second. And then we have got microcurie, 3.7 into 10 raised to power 10 decays per second. And next we shall discuss some other tricks, particularly how to calculate the age of Earth from uranium disintegration and from carbon dating as well. So with these words, before finishing this lecture, I will request all of you to kindly go through these videos, and if you don't like, then comment, otherwise share it. Thank you very much for being with me.